So I guess we're going to go ahead and start. Um, I'm Sarah Cohen. I'm a professor and the night chair in journalism at the Walter Cronkite School at Arizona State University in Phoenix. And I'm going to start with the idea that I spent, 20 years working as an editor at the Washington Post and the New York Times, and tried to learn R maybe 5 or 10 times and just got totally I could write in Python, I could write in other languages, and I never could master it. And in the last few years, all of that has changed. And the reason is, and I'm going to explain why, the reason is that there's a newer way to use R that's not nearly as difficult as it used to be. So what I'm going to do is kind of walk through the ecosystem of what is R, how do you interact with it, how can you get it, it's all free, and what are the things that you could use it for. And then what we're going to do is I'm just going to do a demo to walk through an example, just tiny little project of getting the global COVID data from Johns Hopkins University and converting it into something that you might want to use and showing you how to make even a little chart out of it. So that's what I'm going to do. If you are a little bit more experienced and you already have R installed on your computer, you're welcome to try to follow along as we get started. And I'll try to answer questions. We're going to try to get through a whole demo though, so we might not be able to troubleshoot specific issues. But just let me know if I need to slow down, and do feel free to interrupt with questions. Our moderators are kindly monitoring the chat for questions, and I'm happy to be interrupted because I think it's useful to get things clarified as you need them rather than wait till the end. And I know that's a very US centric way of thinking of things. Is I know a lot of people don't like to interrupt, but you should feel free to. So I just wanted to start with the idea of what is R and why should I use it? And then we're going to get into the demo. So R is, it's an open source free language, computer language, and it was originally created by and for academic researchers. And so it kind of has that root of hobbyists and academics who have very specific needs. One reason that it actually tends to be useful for reporters is that our needs for a programming language are more similar to academic researchers than they are to, say, a bank or a hospital or a university. So the reason is that we often don't have much control over how we get our data, and we don't have much control over what it looks like when we get it. And we just want to use it. We don't want to create it. So in some ways, we have more in common with the academics than we do with the business side of the computer processing world or the technology world. But the thing is, you'll probably never actually use the language R the way it's installed in your computer. Instead, there's a company called RStudio that makes a free way of interacting with R that makes it much easier. If you think about it, you don't interact with the underlying language of Google Sheets. You have a way of looking at it through something else. So the idea is that the language itself is one thing, and how you interact with the language is another. And so RStudio is the way that most people interact with it. It does come in many languages. It's not US centric at all. It's actually a company based in Australia. So, and then there are ways of extending R to make things easier. And that's done with what's called packages. And these packages or libraries are used to make things easier for you. And we're going to talk a little bit about some of the ways that that works. But I first want to think about what reporters use R to do, and then what do they not use R to do. So reporters often use R to clean and rearrange data that you obtain from public records or you obtain from web sources. Um, uh, One reason that I started getting attracted to R was that I could create an actual document that contained both my notes and narrative and my computer code and the results of that code all in one document that's self-contained and can be shared with other people. And in fact, I'll show you at the end of this one way to share things publicly with R. These are called R Markdown documents. Markdown is yet another language which was created basically for Wikipedia when it first started, so that people from Wikipedia didn't know how to write web pages. And so they made this simple way of doing a document. So we're going to combine those two things into reproducible documents. You can usually do almost any analysis that you did in Excel or Google Sheets or any SQL-based language for those of you who have used SQL, structured query language, for larger data sets that are more complicated. A lot of people have moved from Python to R in recent years in newsrooms, not so much in product or in web development, but in reporting, data reporting and data, and in some cases in graphics. It's relatively easy. It's a lot of typing, but it's relatively easy to make interactive and publication quality graphics right in your documents. And the big thing is to use code from others. So for instance, there in the US, there is something called Tidy Census, which makes it much easier to get our census data. The World Health Organization has a package that makes it easier to get WHO data. There's our Twitter that makes it easier to get data from Twitter. So there is some researcher somewhere that has already written a package to make your life easier. And it's always worth checking to see if there's a package before you try to do something yourself. You would avoid R when you have very large data sets. And I would say very large is maybe more than about 5 million rows. And you'd be surprised if you're not that experienced with data, you'd be surprised how often you end up with those. If that's the case, go back to an SQL-based program first for initial processing. R will interact with those databases well, but you don't want to try to load all 5 million rows and do processing with it on your little computer. You'll probably run into some issues there. There's really no good way to hand edit your data. So say you find mistakes and you want to fix your data. There's not an easy way to just like go into your data and type over what was there. And that's because everything that R is really built around the idea that everything should be reproducible. And so you have to do almost everything through code. OpenRefine is one option for using that as a way that's reproducible if you want to just do it more interactively, or Airtables. In both those cases, although Google Sheets does keep a history of your data set, OpenRefine and Airtables has very specific things about what has been changed by whom. And the other thing is you do have to type. You have to type a lot. And there are some things in R that just don't make any sense. As an example, here's a tweet from the other day that says, in most programming language, if you see red, it means something went horribly wrong. In R, if you see red, it might mean everything's totally fine. Just thought you'd appreciate this little note. So one of the things about R is it has not been developed to give, for instance, very meaningful error messages. Some things seem unintuitive. And I think that reflects the hobbyist and specialist roots of it. And so everybody writes something and documentation is not awesome. And so what we're going to do is, in one reason to kind of think about how you're going to interact with R is there's a thing called the tidyverse, which is a whole series of packages that are meant to work together, that have better documentation, that have similar syntax and work similarly on data, so that if you stay within this set of things, it won't be as difficult. So we'll talk about what that means when you have to Google for questions or things like that. On the presentation that you have a link to, I have other resources to learn R. If you're starting from scratch with no background in any other programming language, I'm going to be working from an outline off of my R study guide, which is what I use with my students. It's a work in progress. There are some typos in it, but I can pull it up now and you can see what it looks like. Just going to pull it up. It's basically a textbook, and it starts with the basics: how to get R installed, how to make one of these documents that I was talking with, a markdown, and kind of how you think about data in it. So in that sense, it's for beginners. Mary Jo Webster, who's been quite active with IRE in particular, has a series of videos, if you prefer that, on kind of basic things that you can do with R. There is a textbook called Practical R for Mass Communications by Sharon Mackless, who was one of the first journalists to really embrace R as a way of doing their journalism. The bad thing about that is it's in a very expensive book. It cost, I think, US $65 or more. So it's very expensive, but it's quite good. And she does have a couple of chapters available on her website. Those are all for really people who have no background in data journalism or not much, have never used a programming language before, I'll put it that way. But if you're coming from another programming language, there was a course at the Knight Center for the Americas by Andrew Tran that's called R for Journalists, and the site is still active, and so are all of the tutorials. That sort of assumes a lot of knowledge about how data works, I think is what I would call it. And I've found that for people who have no other programming background, it's quite challenging. But for people who are trying to switch from one language to R, it's quite useful. So you might want to look at that if you're coming from Python or if you're coming from SQL or something like it. If your experience is Excel and Google Sheets, I would stick with the ones with no background and start from scratch. If you're primarily interested in visualizations, which is what a lot of people are with R, Northeastern University has a project called Storybench, and they have R archives that are very common how-tos for visualizations, and they're great examples. So, so that's another resource for you. One of the things that a lot of people ask is, why not just take some of these free courses from Data Camp or go to R for Data Science, which is a free textbook. I think for reporters in particular, I would suggest trying to stick with things that were made for journalists. And there's a very specific reason why, is that in most other resources for getting started with R, first of all, they start with a lot of math and math concepts that we're not that comfortable with usually. They work with vertices and matrices, if you've ever heard of those. There's a lot of modeling done in them for regression analysis and things like that. And it's not really sticking with the simple things that we do in journalism: sort, filter, summarize data sets, join them across things, go get data from the web. They're usually devolved pretty quickly into more complicated tasks that are not things that we usually do. But if you are trying to learn things, there are a couple of really good resources. I would start with, there are some, I can put them in here, but I just tend to find that things that are not made for reporters are not great for people just starting out. So let's get started. I just want to mention, if you're installing R, you have to do it in a sequence of steps. And because there's the language R, and then there's the way we interact with it, which is called RStudio, you will have to first install the version of R for your computer, then install the version of RStudio desktop. And in some instances, there may be a couple of other things you have to install on your computer. And I have a couple of notes about that here. Don't worry about that last part unless you start getting errors trying to do things, saying something isn't installed. But it has to do with how you interact with JavaScript libraries and with GitHub in particular. So sometimes you need it, sometimes you don't. Unfortunately, if you're on a Mac, every version of the Mac operating system, there's a different way to install this command line tools. So I have a link to one way, but you may end up having to Google that. Feel free to reach out to me if you're having trouble with an installation, and I'm happy to help. And I just wanted to also go back to the resources and apologize that all of these are English language. I have not seen a lot of non-English language work that was done just for journalists. But if you know of some, I'd love it if you could put them into the chat and we can share them. I can add them to this presentation so that they're all in one place. So if you know of things, we will add them here that are not in English. And I apologize that this is all in English. So we're going to do a demo. And in this demo, what I'm going to do is give you a little tour of what our studio looks like, how you interact with it, how you get data from the web, and how you can reframe it so that it's working for you. Johns Hopkins University has a global COVID case tracker, but it's done at the state and in the US county level or province level worldwide rather than the country level. So what I'm going to do is show you how you can get that data, convert it into country data, and then we'll see how you can chart it and map it and do other things with it. So what we're going to go through is how the layout of the screens look in RStudio. I find that people are this is the most difficult thing to get used to because it's a very complicated screen. What is the tidyverse and other key packages that are going to make your life easier? How to make one of these self-contained reproducible documents that has narrative, code, images, and results. How to load data from a text file. How to use what we call the basic verbs of the tidyverse, which is filtering, summarizing. There's a verb called mutating and selecting. There are about 6 or 7 words that if you can remember them, then you can do an awful lot. And you'll see some basic charting and mapping. And the result will be something like this. And I'm just going to pull up the version of it that I've made public. And this is what we're going to create. And what you'll notice here is that you can hide all the codes so people can just read your document, or you can show all the codes so people can look at what you did with your computer code. And you have your code, your narrative, and your results all in one document. So you can describe what you're about to do, you can do it, you can see the results of it, and then describe what you saw after that. And so this is what, and you can include images, you can include links to YouTube, you can embed, for instance, YouTube videos. So you can make whole documents from this. And in the end, what you can do is, for instance, make a table that has a list of things. You can chart things, and you can even do an interactive map, this one is really weird because of the way I had to do latitude and longitude. So we're gonna, we have about 50 minutes, I think. And so I'm gonna go through it relatively quickly, but I'm gonna pull it up in R, and so I can start getting you more, oriented to it. So I'm going to stop share now, and I'm going to share a different screen with you. So this is what RStudio looks like when you first start it up. And one of the things that is really difficult for people is there's a lot going on here, and it's actually even more than what's going on here. The environment is something that shows you what's available to you right now, what data sets are available to you right now. Files are what files are included in the folder that you're working in right now, in the project you're working with right now, and I'll show you about that. Packages are what packages have been installed in your computer. And then there's the console, and the console is effectively just showing you how to interact with R and its native state. It's not a program, it's just like a calculator. So if I wanted to just say 5 plus 2, it will give me back 7, but it's not going to save anything, and it's not going to do things in order. So think of it as kind of an immediate response thing. In order to really do anything, what we're going to do is create a document. And I'm going to open a project that I had kept called World Mortality. And in it, when you open a project, you'll see a number of files down here in your file area. And I'm going to make this area a little bit smaller so that we'll be able to see what it's like. And I'm going to pull up just the COVID program that created that web page that I just showed you. I'm going to walk through what it looks like from start to finish. I'm actually going to, sorry about that. I'm going to restart or clear all chunks. Sorry. Okay. Now it doesn't have any of the output left. So now yet another part of your screen has appeared, and this is where you write your programs, is in this section. This one is what's called an R Markdown document. You might also see people use what's called an R notebook. And if you're coming from Python, an R notebook is just like a Python notebook or a Jupyter notebook. The console, really, you're not going to use for anything at all. And so I'm just going to make it small. An R Markdown document has different sections. This section on top is the basic, is the stuff that's like going to be true for the whole document. And so, for instance, what I'm doing here is saying the title of this document is GIJN, what is R? The author is me, the date was yesterday. And I want, when you put this thing together, I want it to be an HTML document. You can change that to a PDF. You can change it to a Word document. There are all different types of outputs you can make. I want it to have a table of contents. I want that table of contents to float. I want anybody who looks at it to be allowed to download the raw code, to download this document rather than having to distribute 2 documents. You can just download it. I want you to be able to show and hide sections of code, and I want to make it look a little nicer by using a theme. And that's all stuff between these 3 things. And what I'm going to do is prepare this document so you can see. I'm sorry, I'm going to change something, preview and viewer pane, so that you can see things next to each other. And to prepare to convert it to PDF, to Word, to HTML, I'm going to do what's called knitting it. I have no idea why it's called knitting it. That goes back to this idea that, like, if you want things to make sense, it's going to be hard. But what it's going to do is knit everything. I don't think it's working. Let me just see. Oh, yeah, it is. And you'll notice that this is the same as this. This is the same as this. This is the same as this. The table of contents is here. And because this is a relatively small document, it's on top instead of along the side. The table of contents exists. It's going to float as I move through the document. I don't think it works on this one, but I have a code download button, and it says download RMD. I have code folding that says show all code or hide all code, and it's got a certain style to it. So that's what it looks like when we're just trying to make an R document. I'm going to close this viewer, and I'm going to just go back to the code. Then in an R Markdown document, you have 3 different types of material. The first one is just text. And in here, I'm just writing what's going to happen. And so all I did was I just wrote out what I'm going to do. And this is a document. It's a walkthrough on how to import data, blah, 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 blah. We'll clean it up, do some filtering, and then chart it. And let's go back to what that looks like when I turn it into a document. It's just text. And the only trick is that this thing with the 2 hash marks turns into a heading. And you can put images in here, you can put links in here, you can put in all kinds of things that will document your code. So this is what I mean by it will create a self-contained, easy to read program that will document your work. So this part is saying, I'm going to set up everything that's going to happen from here on in. A library, I mentioned the Tidyverse. There are several others that are quite useful. You'll start collecting libraries that you want. The big thing to remember is that before you can use a package, you have to install it. Usually, if you open up a document, one of these documents, and it's using a library that you don't have installed, it'll prompt you to install it. But if you need to, that's the one time that you're going to use the console, is to install a package. Just say I want to reinstall Skim, one that I'm using here, which is called Skimmer. I don't want to restart R, but you just do it once and then it's installed in your computer forever. So you only ever have to do the install packages once. Then you can use it. But every time you want to use any of these packages, you have to invoke it in this document. And the reason is that, remember, there were something like 18,000 different packages that you could use. So they don't want to load up your machine with all these packages you're never going to use. I can't think of a time when you're not going to have this library tidyverse command in here every time. These 2 ones, the names of these things are horrible. If English isn't your first language and it doesn't make sense, don't worry about it, because in English it doesn't make sense. So, people name their packages really cute things. So lubridate is just an easy way to deal with dates. And I guess they're trying to make a joke about lubricate as in oil, but it doesn't come across. You'll find a lot of things just stick the letter R either before a word or not. So the names of these packages don't make any sense at all. So don't worry about it. Oh, I didn't show you how you insert a code chunk. So this is called a code chunk, and that is your program. And so as you write your program, you'll write it little piece by piece. So the first thing that we're going to do is just set up our environment, set up what we need to use for this session. And so the way I run the current chunk is just, you can see here, you don't have to have the whole thing selected. You can just see here that there's a green button. You can run the chunk like that. The way you insert a chunk, there are a couple ways with some keystrokes. If you're not going to be able to see my menu, but you'll see what I pulled down. Under the menu of RStudio, there's something called Tools, and there's a whole thing of keyboard shortcuts. So you can get keyboard shortcuts. It's a good question somebody just asked, which is, how would you know which library or packages you need? Well, I can tell you how I learned on it, because I've only been using R for about a year, a little over a year, or maybe a year and a half. But I've done it by trial and error. A lot of what I learned about it was I saw somebody do something that looked really good. that like was something I wanted to do too. And then I looked at what packages they were using. I find that it's really hard to look things up in R. And I think that's what this is a good example of that. Just as an example, this library called Skimmer, and I'll show you what it does in a minute. I couldn't remember the name of it yesterday when I was making this presentation, and I had to actually go back to a program where I had used it to remember it, because trying to Google it, I knew what it did, but I couldn't remember the name of it. So a lot of people have like lists of their favorite packages. Actually Sharon Mackless, again, from the book that I mentioned, has a list of hers, and that's pretty good, and she keeps it up pretty well. I just wanted to show you how you insert your own chunk. This is all stuff that you can ignore. I thought it wouldn't come out, but it won't come out when it's knitted. This is just saying that the tidyverse is loaded. And again, remember that woman saying every other program, when you see red, it's something wrong. And here it's like, just letting you know something. So nothing is wrong here. It's just a mess. If you don't like to look at it, just run it again and it won't happen. If we wanted to insert, and so now the next section is, I'm going to pull up the viewer, and I'm going down to the second heading, which is this. And this is an example of Johns Hopkins makes available the COVID from countries around the world. And this is the link that I'm going to use to get that data. And it has information on its README file. So this is how you make links in our Markdown document. And I just wanted to describe what the data is. And this asterisk, then a space, makes a bulleted list. So just that's what this coding is all about in the Markdown. If you need to add a code chunk, say you need to add a code chunk, you can do it a couple of ways. Under +C, you can do an R code chunk. You'll notice you can also add SQL, you can add Python, you can add D3. Or you can do Control Option I, will also insert one. And you'll notice there are 3 backticks and then R and then 3 backticks to end it. So that's a code chunk. I've already added the code chunk here, and I've called it read raw data. This gives it a name. If you need to navigate your document, each chunk, you can give it a name and then you can navigate through it. This is saying I want to create a new data set in my environment that I want to be able to use. I'm going to read what's called a CSV file, and I'm going to get rid of this so that the parentheses match. And I'm going to read it from the web, from this GitHub. And so when I do that, it basically says, take this data and pour it into, this is the assignment operator, pour it into something called JHU COVID. When I run this code chunk, and again, I don't need it to be done, all of a sudden what happens is I have a data set up here, and I can look at it by clicking on it, just like I could look at a spreadsheet. So here is the data set that it found. And it's got, and you can see what it has in it. It's got what's called a FIPS code and admin2 code. Both of those only refer to the US. It's got the province or state. It's got the country or region, when it was last updated, which was yesterday, the latitude and longitude, the confirmed number of COVID cases, the confirmed number of deaths. They tried to track how many people had recovered and how many active cases there were, but that didn't work out so well. This is a combined key that just combines the province and country, or the state and country, or the county and state and country in the US. This is the rate per 100,000 population. And this is the fatality ratio, which is basically what % of people died that had COVID. So what we'll notice right away is that R gave us a little bit of information about this. What it said was that found 4,006 rows, 4,006 different jurisdictions. It found 14 columns. 4 of them were words. That's what character means. 9 of them were numbers, which is what double means. And 1 of them was a date time. And that's what that is. And you can keep this, and it's telling you if you don't want to see all this information, you can add an option here. Show call types equals false. So it's basically just done, hey, here's what I found. But why are there 4,006 countries? That doesn't make sense. I'm going to skip this part because it's a mess. Actually, I'm just not going to do it because we're doing something else. We've already looked at it, so I'm going to take this out. But the reason is that there is a row for every province and state or state that Johns Hopkins could get. And in the US, there's one for every county. So there are also a lot of things that are NA. So this is the package that I mentioned that I couldn't remember the other day. And I don't need this if you don't, because I've invoked it already. So that skimmer package, this one, gives us a word called skim, which says basically just tell me what's in this data set. And when I run that, it gives me a really nice little set of information. It tells me there are 4,006 rows, 14 columns, and this is the same information we had before. But here are the 4 that are words. How many of them are missing, are not filled in? How big is the longest one? And how many unique entries are there? For the numerics, it'll tell me how many are missing, what the rate of filled out ones are, what the mean, the standard deviation, the lowest value, the first quartile, the median, the third quartile, the highest, and it actually even gives you a little tiny histogram for it. And then for dates, it tells you what the minute, the first and last date is. So it's a nice way to just really quickly look at what do I have. And so what we're going to do is, what's clear is that there are a lot, all but 738 of these rows have what's called a FIPS code, which only really relates to the US. So what if I want to see data as countries, as just the ones that are entered as countries? And so what I'm doing here is I'm going to start with the first verb that you want to look at, which is called filter. And if you've ever used Excel or Google Sheets, filtering is the same thing. And all I'm saying here is show me where province state isn't filled in. And so I just get a list. If I don't pour it into a new data frame, it just prints out. And so when you see this little arrow, you can see what's filled out. The issue is that it's missing any country. For instance, Australia is not in here because they have information by state. And I'm going to try to speed up just a little bit because I want to leave some time for questions. Remind me what time we end at. We end at 9:30 my time, I think. I think that we have half an hour left. So we want something that reverse engineers us to get back to country totals, as an example. The tidyverse has basic verbs that are building blocks, and the ones that we care about are select, which means to pick out columns. And if you've ever used SQL, it's the same as that. Filter means to pick out rows. And if you use SQL, it's the same thing as a where clause. Arrange means to sort the row. And again, if you use SQL, it's the same as order by. And the big thing that's different in this is that if you want to create a new column from an old column, you use the verb mutate. Those are the main verbs. And there's 2 others. We'll get to it. There's also 2 others to summarize things. But if you want to work on every row, this is it. And what you do is when you start with a verb, you use what's called a pipe to connect one verb to the next. And so I put in this image that says, this is how I explain the pipe to stat newbies. The pipe is used to perform sequential tasks. I woke up and then showered and then dressed and then glammed up and then took breakfast and then showed up to work. That's what the pipe does. So if we want to start going backwards, I want to get to a point where I can add up all the numbers within a country and then recreate the rate so that I have a country rate rather than a county or state or province rate. So what I need to do is to reverse engineer their rate per 100,000 people to get an estimated population, which I did in 2 steps just to make sure I did it right. But mutate means, so I start with my original data frame, which is this, and then I mutate to create something new from old, and I'm going to call it rate not per 100,000. I'm going to take the incident rate and divide it by 100,000. The variable names are case sensitive. We'll talk about that a little bit later, but they are case sensitive. So if you're having trouble, do it. But just notice what happens if I try to, if I got rid of that and I started typing it. You'll notice it prompts me to get the right thing. So I can just hit the tab button and it will fill it out for me. And I'm saying the estimated confirmation is the confirmed number of cases divided by that rate. And so if I run this code, I now have a new COVID counts that at the end has the estimated population for each of these rows. Now, what I want to do is summarize by country. And this is a direct corollary to if you have ever used pivot tables in either Excel or in Google Sheets, it's exactly the same idea. And if you've ever used group by in SQL, it's the exact same idea. So what I want to do is I want to take all of those rows, those 4,006 rows, and I want to collapse them so that the only thing that's left is the country. And then what I want to do is I want to add up the number of cases, the number of deaths, the total population, and I'm just picking out a latitude and longitude, and you'll see how in mapping this isn't going to work out very well, particularly for the UK, but that's okay. In R, the one thing that you kind of want to make sure of is what happens if something is missing. And in order to do that, you do something called NA remove equals true. You can get into trouble with it, but not a lot of trouble with it. But if you don't, if something is missing, it will create a missing outcome, no matter whether, if one of those 4,006 rows didn't have a confirmed total of number, if it was just missing, everything would be missing. So instead, I'm just saying, I just want the confirmed, I want to just ignore anything that's missing. And that's what that is. I don't think that there's a way to set that up as a default. So let's see what happens now when I do this. I've now gone from 4,006 rows to 196 rows, and I've gone from 14 or 16 columns to 6 columns. And let's take a look at it. I've now got the country and region, the number of cases, the deaths, the population, and basically I want to stick a point on a map. This is where I would stick it. Again, it didn't come out right, but that's okay. So now I can now go back and start with it. And I'm just going to make you a nice table because this is a little hard to look at. Let's just make a nice looking table. And that's what this reactable library does, is make something that's a nice looking table. And I'm just giving you some examples of what you can do. So now if I say I happen to know what the US population is, so if I want to check my data, I want to look for the US. And I do know that we have, at the time that they're looking at this, about 332 million people is about right. So, and about 45 million cases is about right. So I feel like I added up the US at least correctly. You can search, you can also sort. Say I want to just sort from the smallest to the highest the highest population and looked at the biggest countries, the most deaths, I can sort that. So this is just a super easy way to do it. If you just want to play around with your data, you can pop this open, and I'm not sure you'll be able to see this, but I'm going to pop it open into a new window, and I don't think you can see it, but it's got a whole new window open where I can play around with it. So if I wanted to now see what percent of the worldwide cases each country had, we can now start doing more math. So the confirmed total over the sum of the total, and I can just run this. And one of the things that I hate about R is that if you don't make one of those fancy tables, you don't get nicely formatted numbers. And I remember somebody who makes the tidyverse, his name is Hadley Wickham, and he's the chief data scientist for RStudio, which is the company that makes this program. But he's also the idea of the person who made the tidyverse. He's kind of the tidyverse god. He once put out a question, what would you like to see next in the tidyverse? And a whole bunch of people said, is there an easy way to make nice looking numbers that I can read? Because they don't have separators in them. They don't have percentage signs next to them. It's actually not that easy to just show a few of the, you have to round them in order to not show all of the digits. There ought to be some defaults that you can do that would just make it easier to look at numbers, but it's not. So you have to kind of work with those fancy things. But you can at least see it. Again, you can pop this out and look at it in a new window if you want to see more of it. It tells you there are 196 rows with 3 columns in what we just figured out, because I had only selected these 3 columns. That was one of our verbs, is to just pick out 3 columns, and it's sorted by the percent of cases. It should have been sorted by percent of cases. That doesn't make sense, does it? Makes sense. That's wrong, so I'll have to fix that. But we will get the rate per 100,000 residents. And so we wanted to go back to the data that they had. So here what I'm doing is saying, take this data frame, this counts to, and now calculate a rate per 100,000 people, the confirmed total divided by the estimated population times 100,000, and recalculate that death rate. How many deaths divided by how many cases times 100. And I'm just going to do that. I now have another data frame that I can use. It's got 8 variables. You can also look at it here and see what the names of things are if you need to. And so one of the things I'd like to do is just see a chart of death rates, of this death rate for the 20 largest countries in the data set. And you'll learn some of the different verbs that are not the ones that I've mentioned. But what you'll find is that most people use a package called ggplot, which is part of the tidyverse. So it comes with the tidyverse. Most people use ggplot for plotting. And what this is saying is take the 20 highest populations, slice them off because the max. And now I'm going to make a chart of them. And the big thing, again, if you want R to make sense, it won't. We talked about the idea that the pipe is the word and then, but in plotting, and then is a plus sign, which just totally sucks. But it's a pretty easy way to make a reasonably nice looking chart, right? It's like, it's not that bad. And that was basically saying, I want to use I want to sort this country region by the death rate, so I get the highest one on top. I want to plot the death rate on this axis, and I want to fill these bars with the color blue. I want this axis to go from 0 to 8, I want to flip the coordinates. So what would normally be up and down is now sideways. I want to use a theme that gets rid of a lot of junk. And I want to relabel this to percent of cases ending in death. So that's really the basics of how to make a very simple chart. I will, the last thing that I'm going to do before I open it up for questions or comments or ideas, and I'd love to hear your ideas as well, is some people might be familiar with a package that you use a lot if you're in web development called Leaflet, which is a way to make maps, interactive maps for the web. Just like Reactable, the way we made this chart up here is another example of that. There are several things you can do with our Markdown documents that are basically borrowing JavaScript libraries from and then adapting them to R. So React is one, Leaflet is one. There's, I think if you use data charts, there's a whole lot of them, but I'm not that good. I don't know web development at all, so I'm not very good at knowing what is out there, and I have trouble with the language of it. But basically, this is just saying I'm going to make a leaflet map out of this, and I think I mentioned that our approximate latitude and longitude are not very good, but we'll do that. Usually when you're making a circle, you have to do a square root of something. And then I want a pop-up of something. I am not that good at this syntax. I just have to go by examples. And so, so I just have to go by examples and trial and error. But basically what you do have is an interactive map that gives you the rate per 100,000 people for countries. I will show you what, and that they've got bigger circles where that rate is higher and smaller circles. Let's go into Australia, smaller circles where it's smaller. Here's what I don't know how to do. I don't know how to scale it as you move in so they stay big. And the way that I got the latitude and longitude, the UK is way down here. And that's because I used, I think that the UK had latitude and longitudes for some of the territories that are in the Caribbean still. So it was somewhere between the actual UK and the Caribbean is where it ended up. So this is actually Ireland. But it's a basic thing that for reporting in particular, you might be able to do. This is just good enough for your reporting purposes, for instance, to say, where am I going to go? There are obviously really complicated ways of doing graphics and all of those, everything in R. Some people use it for publication quality graphics. I know at the New York Times, when I was at the New York Times, Amanda Cox and a lot of the graphics, particularly the people who were good with statistics, the folks in the visualization side would use R for sketching before they brought things into a more of a publication ready thing, because they felt like they could just play around with things relatively easily in R. Just in terms of how other news organizations use it, at the AP, for instance, all of the reporters distribute, all of the data reporters at the AP use these R Markdown documents and share their data with other reporters through these documents, so that you don't have a whole bunch of spreadsheets getting sent back and forth. No, use this one. No, don't use that. Use this. This is saved as on Amazon, just in an Amazon bucket. It's not even a web server. It's just a static web page, and they can save it and just always update that document so that everybody is always looking at the same thing. And so that, they can explain what they're seeing in the data, and they can also explain what reporters should not take away from something. So when you're working on a team, this is a really good way to share data and to make things again. And I'm just going to again show you, I'm going to stop my sharing now. And again, show you what it looks like somewhat finished. And again, I'm just going to show you what this looks like now that you've seen how it's done. Again, this was the heading information. This is the heading of what I'm doing. I can show and hide these code chunks. I have some documentation on the data set. This is how I read in the data. This is a code chunk, and this is the result. This we took out, but that's okay. Here's that thing where I was talking about skimming it and seeing all the different things you can do with it. Let me make this a little bigger. And you can just walk through and see how this converts into a document that you could share with somebody. And that's what we ended up with. So just so you know, this RPubs is a place, if you don't mind it being public, everything on here is public. There's no way to make it private, but RPubs is someplace you can just stick your Markdown documents once they're done if you want to share them. So it's a little harder if you want to share them privately, but if you don't mind that the whole world might stumble on it somehow, I can tell you I have never once stumbled on somebody else's RPubs. You can just publish it to RPubs. You just make a free account. So going back to basics, I just want to take a look at some of the questions. How do you I'm going to start with how do you export all of your output into a separate document? And how do you create embed codes for data vises you create, for instance, this map? I don't know about the embed codes. Let's see if I can. You can save a data frame to a file and then refer to it in a new program. I will just, as I'm going to switch the way that I'm sharing. It's a little bit confusing. I'm going to switch the way I'm sharing so that I can have both R and my doc and my document up, but sorry. So I'm going to share again. So if I wanted to share, if I want to save this data for later, what I can do is just say, I'll do it in the console, even though, again, the console is used, which you just want to do something little. I can just save, for example, JHU rates file equals JHU rates. And then it's usually called an RDA file. And what you'll notice now is that I have this new thing in my list of files, and I can just load it. And that way you don't have, you can save things across sessions of our Markdown. When I downloaded, it asked me to download Xcode. Is that necessary to run RStudio? Not all of Xcode, but that's where that command line tools comes in. It depends on what version of a Mac you're using, which one you use. You might have to, I have a copy of it saved somewhere depending on your version. So if you want to just tell me what your version is after the session, I can help you with that. You actually don't need it for a lot of what we're doing, but you might as well get it because at some point it's going to bite you in the butt if you don't have it. I don't know how to create embed codes. I don't know what you mean for that. I think what you're talking about is how do I save it and then embed it in another thing. This is called an HTML widget, and you can just save it as a widget. I don't really know much about that, but you can just save this instead of printing it out, and then you can use it elsewhere. So I'm not exactly sure, but there is a way to save it. I haven't done that much. So again, I've always done this more as a reporter than as a producer. So I'm not that good at it. Um, Another question is it easier to scrape data using Python instead of R? A year ago, I would have said absolutely yes, Python is much better for scraping. The scraping library for R was completely redone about maybe a few months ago by Hadley Witham. Again, you'll hear that name a lot. And it appears to be much better now. I you yeah, I think that you should scrape in whatever language you know. Like if the only reason to learn Python is because of the scraping and you're learning your first language, you can do it in R. But if you already know Python and you're switching to R, scraping is one of those things that you might want to stick with in Python. Is it possible to, yes, it is possible to publish the charts or maps directly on the website via a link. Yes, you just save it wherever, instead of, this here is, I'm not saving it as anything. You can always save this as an image anywhere you want. And you can do that by actually just saving it instead of creating it as something. And then it's where you direct the output. In this case, I'm directing the output to a screen. I don't have the syntax for that right on top of my head, but instead of saving the syntax, instead of printing it to the screen, you would just save it as a JPEG or whatever in here. And down here, you would just save it as an HTML widget, which works with JavaScript. So instead of putting it out to the screen, you would put it out to a file wherever you want to keep that file. So wherever you want to do that, you can do that. I just don't have the code right in front of me on how to do that. Do I find R easier as a professor to teach than Python? Yes, I do. I think one reason is actually because the question is, do I find it easier to teach R versus Python? It's funny because we have 2 graduate level data journalism classes here at ASU, and the other one is taught by an adjunct who teaches it in Python, and I teach it in R. So we've got 2 semesters of overlap now with 1.5 semesters where we've been doing it the different ways. I found R a little easier because of this pipe notation, frankly. The thing about R is that you can teach students to do one thing at a time. So just as an example, I can say, first, let's see what happens when I do this. And so now I've created something that's just a copy of another one. Now I just want to say, I'm just going to say, do one calculation. Let's see what happens when you do this. Now let's see what happens if you arrange things. If you sort things. So what you can show people is how different things happen one thing at a time. In Python and Pandas, you tend to have to do everything all at once. There's also a lot of notation in Python that can really throw students, which is where you always have to use something like this data frame, and then you have to put some variable here, and then you have to, the notation can actually throw students a lot because it's difficult to use. So I found that the more English version of R, or the more, now I shouldn't say English because it comes in out lots of languages, the more natural language version of R makes it easier. And that was not true until the tidyverse came around. That's why it was impossible before the tidyverse, is that all of this stuff is part of the tidyverse that makes it easier to use. So if you're not using the tidyverse, no, I think Python would be easier. if you are using the tidyverse, I think R would be easier. The other reason that I tend to gravitate to R is that there are some newsrooms, at least in the US, where for interns, they require at least a passing knowledge of R and the tidyverse. But there are none that require a passing knowledge of Python. Usually, if they want Python, they like, if you know any language, you're fine, it doesn't matter. But with R, people tend to want that a little bit more specifically. So, and I think that has to do with what the difficulty used to be, but I also think it has to do with the way that they communicate within their team. Um, Jupyter notebooks are not standard in newsrooms that much, but our notebooks, these are markdowns, and our notebooks are pretty much the way that people communicate in R. And I think that we're good. On the last page of my presentation, you'll see a link to the walkthrough that we just did, and you can download the R Markdown. If you're having trouble with that command line tools thing, just email me and or hit me up on Twitter, and I'll help you with it. And if you need anything else, all my contact information is on the last page of that presentation. So thanks for coming, everybody, and have a great conference.